Hello everyone, my name is Disha Kansara and my SEP ID is 60001198003, and today I'm going to explain the designing of Schmitt trigger and its some applications. So first of all, we see the inverting Schmitt trigger using op-amp. Then we see the develop and a stable multi vibrator based on the Schmitt trigger. Then for this modified of the stable multi vibrator to form a triangular wave generator, and then we'll see the modification of the stable multi vibrator circuit to form a sawtooth wave generator. So the first of all, we see the Schmitt trigger operation. So this is the circuit of inverting Schmitt trigger. So first of all, the Schmitt trigger is an electronic circuit that adds the hysteresis to the input-output transitions threshold with the help of the positive feedback. Where the hysteresis here means it provides the two different threshold voltage levels for rising and falling edge, where essentially Schmitt trigger is a bistable multi-vibrator and its output remains in either of the stable state identify indefinitely for the output to the change from one stable state to the other. The input signal the input signal must change or trigger uh, appropriately. So where the bistable operation of the Schmitt trigger is require the amplifier with positive feedback with the loop gain greater than 1. Hence the Schmitt trigger is also known as regenerative comparator. So this is the short information about Schmitt trigger. And for the hysteresis, for the reference voltage, plus Vref and minus Vref are called the upper threshold voltage and the lower threshold voltage. This is the circuit of the astable multi-vibrator. So the op-amp multi-vibrator, which is a stable oscillator circuit that generates a rectangular output waveform using RC timing network connected to the inverting input of the operational amplifier and a voltage divider network, and it is connected to the non-inverting input. So the monostable or a bistable, the astable multi-vibrator has the two state, neither of which are stable, as it is continuously switching between these two states with the time spent in each state controlled by the charging or discharging of the capacitor through a resistor. So in multi-vibrator circuit, the op-amp work as an analog comparator. So the RC circuit that the capacitor wants to charge up fully to the value of V out, which is plus V set, and within a 5 times constant. However, as soon as the capacitor charging voltage, the op-amp inverting terminal is equal to or the greater than the voltage at the non-inverting terminal voltage fraction, which is divided between the resistor R1 and R2. So the output will be change state and given and be driven to the opposing negative supply rail. So but the capacitor which is has been charging towards the positive supply plus V set. So now it sees the negative voltage minus V set across the plates, and sudden reversal of the output voltages causes the capacitor to discharge towards the new value of the V out at the rate dictated again by their RC time constant. So this is the short information about the stable multi-vibrator. So first of all, let's see the inverting Schmitt trigger designing. So this is the calculations of inverting Schmitt trigger, where my R1 is my R1 is 1.5 kilo ohms, R2 is 1 kilo ohms, where V out is approx minus 6. So let's see the circuit of it. Yeah, so this is my schmitt trigger circuit diagram, which I already performed, where my R1 is 1.5K. I used the OPAM OP07, and my input is given a sine wave, where I given a 8 volt, and I given a frequency of 50 hertz here. And yeah, the voltage source for VCC and VEE, I applied a plus and minus 15 volts. So let's see the output. So yeah, this is the output of the Schmitt trigger for the 50 hertz, where I get the output value, which is input wave is my 8 volts, and I get the output waveform, which is across 13.87 volts. So yeah, this is for the 50 hertz. If I change the frequency of the input voltage, so let's see, for 1K, sorry, I just change my transient time. So yeah, now I will change again my transient time to see the more perfect waveform. So let's say 20 milliseconds. Yeah, so this is my input voltage for 8 volts, and I get the output of 13.92 volts. So this is my output in the different frequencies. For the another one frequencies, I already performed, where 50 hertz, this is the output of 50 hertz. This is for the 500 hertz. This is for the 1K. For the 5 kilohertz, I get this output, and for 10 kilohertz, I get the output which is above the input voltages. So yeah. So let's see the next one, which is a stable multivibrator. For this, I written already the calculations, where my T is equal to 2 RC ln 1 plus beta upon 1 minus beta, where beta is my R plus R1 plus R. So my frequency 1 kilohertz. So I get the RC value, which is 590.319 into 10 raised to, yeah, so the capacitor value is 470 nanofarad, and I get the value of R resistor, which is 1.2 kilo ohms. So this is my circuit of the stable multivibrator. Let's check the output for that. Yeah, so this is the circuit of the stable multivibrator where my I given the input I given the capacitor which is 470 nano. My load resistor is 1.2k. I used OP07 op amp, and I gave R1 and R2 which is 1.5 and 1k, and voltage source is a plus and minus 15 volts. Yeah, so this is the waveform for the stable multivibrator where in the input I get some sawtooth type waveform, and at the output I get the square type waveforms. So this is the input voltage which is approx 5 volts, and the output voltage is around 13.66 volts. So this is the a stable multivibrator using op amp. Yeah, this is the ram generator which is also called a triangular wave. So we used in this we used the Zener diode. So let's see the circuit of this. Yeah, so this is the circuit of triangular wave where I used two OP07 here, and let's see the output of this. Yeah, so where I get the triangular wave in the output, which is output is approx 0.23 volts, and my input voltage is around 7 volts. So this is the circuit of ramp generator for the frequency of 1 kilohertz, and the last one is a sawtooth wave generator which is already I have performed too. So let's see the circuit of this. Yeah, so this is the circuit of sawtooth generator where I use the Zener diode here for the output of first stage. So let's check the output. Yeah, so where in the output I get the waveform of sawtooth wave, where the which is around the 7.2 volt output waveform, and my input voltage is 10 volts for the frequency of 1k. So this is my the last circuit. Yeah, so thank you.